All right, welcome to the next installment of comparing linear and exponential functions. And in this video, we're going to focus on comparing and contrasting tables of values and deciding if they represent linear or exponential functions, and then kind of picking them apart and using them. Okay, so here we have an example of a table that's going to be linear, okay, and it's not filled in yet, but I wanted to pick out the important things for you, okay? One thing I want you to notice is that the x values, they don't have to be consecutive integers, but they are going to vary in our table with the same common difference, okay? So we're adding the same thing to go from x value to x value. And in a linear function, that will be true with the y values as well, but it does not have to be the same difference, okay? So if I'm adding 4 to get from the first y to the second y, I'm going to have to add 4 to get to the next y as well. And so the next y value will be 9, and then I would continue that process. I'd add 4 more, I'd get 13, I'd add 4 more, I'd get 17, and I'd add 4 more to get 21. Okay, so this completed table represents a table of values for a linear function. We're going to remember that the equation for a linear function looks like y equals mx plus b if we're talking in slope-intercept form, which we usually do. And then we're going to identify the slope by thinking about it as the change in y over the change in x. So right here we see our change in y. All of these I'm adding 4 to, so that is going to be our change in y. And then the change in x is up here. All of these are going to be my change in x. So my slope is going to be positive 4 divided by positive 3, which is going to give me 4/3, which will be our slope. We'll sub that in for m. The other part of the equation is the b, which is our y-intercept. And we would find this by looking at our graph for the coordinate that has an x value of 0, okay? And so that's going to give us our y-intercept, and we can plug that in right there. So then our final answer for the equation that represents this data is y equals 4/3 x plus 5. Okay, so now let's look at a different example, and we're going to look at an exponential table. Okay, now notice that, again, we have not filled it in, but we're going to fill it in, and the x values differ by 1. We're still adding the same amount in this exponential function for the x's. The y values is where it is a little bit different. The y values are going to be multiplied. Okay, so you need to look and see what is 1 multiplied to get 3, and that is definitely 3, right? 1 times 3 is 3. So to get to my next y value, I would multiply by 3. Okay, and so that will be 3 times 3 is 9. Multiply that by 3 to get 27. Multiply that by 3 to get 81. And multiply that by 3 to get 243. Now recall that our equation for an exponential function looks like this. Y equals a times b to the x. So what we're going to have to identify is what is our multiplier, and that's pretty evident by just looking at what's going on in the function. We are multiplying by 3 for that y value every time. So 3 is our multiplier. That's going to go in for b, and we can find our y-intercept by looking at our table where x equals 0. So we can put those in the appropriate places and write the corresponding function. Okay, so here are a couple of tables, and we don't know what they represent. So in these two examples, what we are going to do is determine the equation of the function that they represent and then find a specific function value. And in this case, we're going to find f of -4. So let's focus our attention on this first table. The way we would handle this is we would definitely double check and make sure that all of our x values increase by the same number every time. So we have a common difference of 1 here. And then we would look at the relationship of the y values. So to get from 80 to 40, there's a couple of different ways to do it. I can either add a negative 40, or I could multiply by 1/2. And you always want to think in terms of addition and multiplication. Okay, so in order to figure out which kind of relationship we have, we need to go and see which of those things happens again to get from 40 to 20. Okay, so if I think about 80 plus negative 40 to get to 40, if I added a negative 40 again, I would get to 0. So that means that I'm not adding a negative 40 every time. Let's try multiplying by 1/2. Half of 80 is 40. Half of 40 is 20. And that relationship continues. So I can say that I am multiplying by 1/2 every time. Since we have a multiplicative relationship here, it's an exponential function, and so we're going to sub the appropriate things into the a and the b. A will be our y-intercept, and b will be our multiplier. So we would end up subbing those things in here, and we would have our function. F of x is equal to 80 times half raised to the x. Now the last part of this example asks us to find f of negative 4. So all we really need to do there is sub in a negative 4 wherever I see x and then evaluate. If I take 1/2 and raise it to the negative 4 power, I just get 16. So I am looking at 80 times 16 as my final answer. And there we go. All right, so let's look at the other example here. I have another table, and I'm looking at what's going on with this table. Double checking my x's are going to increase by the same number every time. And then we're going to look at the y values. How do you get from negative 40 to negative 37? Well, you actually can get there 2 different ways. You can get there by adding 3 or multiplying by 37 over 40, which is a little bit strange, but you could do it. All right, and so we want to double check and see what is the continuing pattern so we can establish, is this a linear or exponential function? So if I'm adding 3 here, do I do that to get to the next y value? And I do. Okay, so I can tell this is an additive relationship where I'm adding 3 every time. So that does mean we have a linear function. So let's go ahead and sub in the appropriate things. Let's find our slope by thinking about delta y over delta x, the change in y over change in x, which is going to be positive 3 over positive 1, which is 3. And that's going to sub into our m. And then our y-intercept will be found in our table where x is equal to 0. So I can sub that into my function, and now I can evaluate f of negative 4. F of negative 4 is 3 times negative 4 minus 31, which is going to give us negative 12 minus 31, or negative 43. All right, in the next video, we're going to talk about the difference between the graphs of linear and exponential functions. I'll see you then.